All right, this is Physics 102, Exam 1 for Spring 2015. Doug rubs a piece of fur on a hard rubber rod. What, given the rod a negative charge, what happens? All right, if he gives it a negative charge, that means that electrons are being added to the rod. Protons are not being removed from the rod. The fur actually is not left neutral. If he's giving electrons, then the fur is left with a positive charge, and the fur is not charged negatively. Um, Metallic object holds this amount of charge. What total number of electrons does this represent? So I just say, just 3.8 times 10 to the minus 6 divided by 1.6 times 10 to the minus 19. This is the number of coulombs per charge for an electron. So the number of coulombs per electron, this is the number of coulombs. So it leaves me with the units of just number of electrons. So that's 3.8 e to the minus 6, or 10 times 10, times 10 to the minus 6 divided by the fundamental unit of charge. I get 2.4 times 10 to the 13. That's like 2.375. What of the best characterizes electrical conductors? Electrons move freely. Usually conductors are good heat conductors. They might have a low mass density, but maybe not, and it doesn't matter about their tensile strength. If I bring a negatively charged plastic rod but do not touch the end of a neutral copper wire, what happens? Well, if I have negative charges here, that means all the negative charges rush down here, and I'm left with a net positive charge, and that's going to be attracted to the negatively charged rod. So A is the right answer. Two charged balls are repelling each other. What can you say about their charges? Well, either they're both positive or they're both negative, because they're repelling. I have a negative Q charge that sits here. Where does the force vector lie, or in which of the quadrants? Okay, so the force due to this charge is going to be in this direction, and the force due to this charge will also be in that direction. The force due to this charge will be in this direction, and the force due to this charge will be in that direction. So those two charges will cancel out, giving me a net force in this direction. So that's in quadrant 2. If the distance between two negatively charged ions is doubled, the force on one of them due to the other will, which of these? Well, force is KQQ over R squared. I'm doubling this distance, so the force will be down by a factor of 4. So it would decrease by a factor of 4. What is the magnitude of the force on this 5 nanocoulomb charge? Okay, well the force is KQQ over R squared. That's going to be 9 times 10 to the 9th. 5 times 10 to the minus 9. 10 times 10 to the minus 9. Divided by the distance. This distance is 5 meters. You can say the square root of 3 squared plus 4 squared. Square root of 25, that's 5. So 5 squared. Alright, so let's see. Some cancellations here. This 2 5s cancels with that and just leaves a 2. That gives me 18 times 10 to the minus 9 newtons. That's G. For the figure, what is the direction of the force on the 5 nanocoulomb charge? All right, let's see. The force on this charge is going to be attractive. It's in that direction. So I want to know what this angle is. Let's see, this angle, if I say the inverse tan of 4 over 3, I'll find that it's equal to, what's that, 53 degrees. So this is 53 degrees. This is 37 degrees. That's 90 minus 53. Or I could have said the inverse tan of 3 over 4 and gotten 37. But that leaves this angle at 53 degrees. Now let's look at our options. It's 53 degrees below the positive x-axis. Which is an option. But let's look at these others. It's not above the positive x-axis. It's not 45 degrees. Is it 37 above the positive x-axis? No, it's actually below. And it's not below the negative x-axis. Okay, so C is the right answer. Okay, what is the force on Q1? Let's see. So I have 2 forces acting on this. Due to Q2, it's in this direction. I'll call that F2. And then Q3, it's in this direction. I'll call that F3. Okay, now look, I can look at this and well, let's just work it out, and then I'll show you. So F2 is KQQ over R squared. That's k times 1 times 10 to the minus 6, 1 times 10 to the minus 6, divided by the distance squared, which is 0.2 squared. Let's go ahead and write out f1. Actually, that should be f3, which is going to be k 4 times 10 to the minus 6, 1 times 10 to the minus 6, divided by the distance squared, which is 0.4 squared. Okay, now look, I can go ahead and do all this, and I'll calculate this in just a second, but let me show you. This distance here is twice the distance here. All right, that means that the force will be down by a factor of 1/4, like we saw in the previous problem. But notice that this charge here is 4 times this charge here. So while I get a factor of 4 in the denominator, I get a factor of 4 in the numerator too. So that means that the forces are going to be equal, F2 and F3, and they're opposing one another. So A will be the right answer. Now, we can go ahead and we can work this out. That's going to be 9 10 to the 9th. I get 0.225, and you'll get the same here, 0.225. All right. But you shouldn't have to go through this calculation. You should be able to see that this charge is 4 times this charge, and it's twice the distance away, so those two things are going to cancel out. This diagram shows 3 heavily charged plastic cubes. The net force on cube 3 is shown. If cube 3 is positively charged, what are the charges on cubes 1 and 2? Okay, well, let's look at the force due to particle 2. The force can either be in this direction or in this direction. Now, I know cube 3 is positively charged. I know that this force won't give me. Actually, let's not say that. Let's go ahead and draw the other forces. Then I think you'll see it more readily. All right. Due to cube 1, my force can either be in this direction or this direction. All right. In order to get this force, I'm going to add up these two vectors. All right. So that means that cube 1 will be negative and cube 2 is positive. So C is the right answer for number 11. Proton is 3 meters from 1 nanocoulomb charge. What initial acceleration does it experience? Well, F is k QQ over r squared. Proton has a charge 1.67, 1.6 times 10 to the minus 19. Divided by the distance, which is, what, 3 meters squared. This 9 cancels here, that cancels with that, and I'm left with this just 1.6 times 10 to the minus 19 newtons. All right, so the acceleration then problem here. I'm going to pause for just a sec. Okay, so the acceleration then is A is F over m. That's that 1.6 times 10 to the minus 19 newtons over 1.67 times 10 to the minus 27 kilograms, which is, those basically cancel out. 1 times 10 to the 8th, which is C. That was actually a question from another old test. What is the magnitude of the electric field at point A? Okay, well, I have two vectors. I have due to this charge, the direction will be in that direction. Due to this charge, will be in that direction. So I want to figure out what those two are, and then I'll use the Pythagorean theorem to find what is the resultant of it. So I have let's do this one. I'll call this one E1. That's KQ over R squared. 9 times 10 to the 9th. 5 times 10 to the minus 9. Divided by 4 squared. Let's see, that cancels. That's 45 over 16. I'll just leave it as a fraction for now. And then I'll call this E2. It is equal to 9 times 10 to the ninth, 10 times 10 to the minus 9. Notice I'm not putting the signs in there. Over 3 squared, that cancels, I'm left with 10. All right, and then I do the square root of these because I want to know the resultant of this vector. So I say the square root of 45 over 16 squared plus 10 squared. I get 2.8. Oh, that's not right. Hold on. I get 10.3, 10.39 or 10.4. So C is the right answer. Let's see, that was number 13. Consider these two charges and their resultant electric field lines. If Q2 is plus 2 coulombs, what is Q1? Well, first of all, I know that Q1 is positive because its lines are coming out. I have 4 field lines over here. I have 4, 8, 12, 16 over here. So I have 4 times the charge over here, and it's positive. That's going to be plus 8 coulombs. Charge of plus 2 coulombs at the origin. When a charge Q is placed 2 meters along the positive x-axis, the electric field becomes 0. What is the value of Q? Okay, so I have an electric field due to this charge in this direction, and then I have an electric field due to this charge in this direction. All right, so I know that has to be negative, but look, all the options are negative. So let's think about this. I have a charge that is half the distance, right? So remember, E is KQ over R squared. I'm going to go ahead and call this E1, and we'll call the one here E2. That's going to be 9 times 10 to the ninth, 2 coulombs over 2 meters squared. All right, and due to this one, E2, that was E1, it's going to be 9 times 10 to the ninth, Q over 4 meters squared. All right, so I'm getting this distance is twice this distance, and so I get a factor of a quarter here. That means Q has to be 4 times as big. That means Q has to be 8. We can show this. Let's see. I'm left. Get rid of one of these. I get 4.5 times 10 to the minus 9, and then I just set that equal to this. Just double check that. Solving for Q here. Yeah, I get 8 coulombs. All right. 4 coulomb charge is mass at 5 kilograms. The rest and release an electric field of magnitude 50 newtons per coulomb. Charge begins to move. How fast does it move after 2 seconds? All right, so F equals QE. That's 4 times 50, or 200 newtons. And then I want to know the acceleration is F over m divided by 5. What's that, 40 meters per second squared? And then I want to know how fast it moves. So V is equal to AT. 2 seconds, it's going to move at 80 meters per second. So C. Which C is not a unit for electric field. All right, well, that is a unit. That is a unit. This also is a unit. Remember, newtons per coulomb. Newtons is kilogram meters per second squared per coulomb. So that's the same. So all of these are units. What point is the magnitude of the electric field the largest? It's where the lines are closest, so that would be B. You're sitting a certain distance from a point charge. You measure a field of E naught. Distance from the charge is halved. What is an electric field? Well, if you get closer, your electric field is going to get bigger. So KQ over R squared, if I have this, I get a factor of 4 over here. Figure if there's 3 charges, what is the potential at point P? Right, so I have KQ over R squared for all of these. So I have negative 20, excuse me. I'll do them over here. KQ over R, excuse me. V is equal to KQ over R. That's 9 times 10 to the ninth. Negative 20 times 10 to the minus 9 divided by 1 meter. Down here I get 9 times 10 to the ninth, 10 times 10 to the minus 9, divided by this distance, which is the square root of 1 plus 1, 1 squared plus 1 squared, square root of 2. And then I got this one, which is going to be 9 times 10 to the ninth, 20 times 10 to the minus 9, divided by 1 meter. Alright, so I can go and cancel some of these out. This gives me negative 180. This gives me positive 180. So those two potentials cancel out. So I'm just left with whatever this is. 90 over the square root of 2. It's 64. Yep, C is the right answer. Which of these is a conservative force? All right, these two are, electric and gravitational, so 1 and 3. Which of these points is 0, the potential? All right, the point where our distances are equal. Looks like right here. This was actually an old test question. These distances are all equal, so the potentials all cancel out. Negative charge moves along equal potential lines. Which of these is true? The force on the charge is opposite. Okay, that's not true. 0 work, B, is required to move the charge. It doesn't experience a greater change. This also isn't true. Electric potential is a measure of energy per charge. Negative charges, remember if you forget this, as I always do, if this is positive and negative, this is high potential, low potential. A negative charge would move in this direction, so it would move from low to high. So B is. And let's see, which of these is my favorite student? I don't even know any of these people. Right, so not me, but you. So hopefully you got that one right. And here are the answers for this version.